Привет всем, кто уже с нами. Привет всем, кто будет присоединяться. Привет всем, кто будет смотреть в записи. С нами сегодня Бауыржан Абакир, директор ком- команды Data Science и Machine Learning в Русскомбанке. И сегодня будет лекция по рекомендационным системам. Она будет на английском, да? Вас слышно? Хорошо.
Да, меня хорошо слышно?
Да.
Да, всем привет. Лекция будет, на самом деле, на миксе языков. Я постараюсь ее вести на английском. Но так как у нас бизнес ведется там на русском, казахском языке, возможно, будут вставки на русском, казахском языке. Вот. Everyone, thank you for joining. My name is Baurjan Albakir. I work at Jusam Bank as a director of data analytics and machine learning department, which is technically a data science department right now. So thank you everyone for joining in at this Friday evening, antisocial Friday evening. Also with us, I have Ruslan Bajenov. He is our main he is our main recommendation system engineer, and he is one of probably the most qualified persons in Kazakhstan to do such job. So let's start about our topic. We will talk about applied recommendation systems. So basically about recommendation systems that are used in real life, in real systems, and they get the feedback from the real customer. So basically there is no simulated data, there is no assumptions. Basically it's fully and truly experimental project. Basically you recommend something, you see how users react to it, and then you adjust your strategy. Basically it's pure experimentation, and it's actually one of the most fun things to do in the bank. So we will talk about how we make the products personalized, and also how we try to make you to buy them. So let's start. So first we will start about the classical recommendation systems. Those are collaborative search and content-based filter search. And then from the recommendation, we will tell you how we basically how the companies and how basically everyone manages from personalized recommendation basically to adjusting the user experience and the user interfaces in order to be more personalized. So recommendation is just one thing. We offer you this and that, but personalization is basically the interface of your mobile app gets adjusted especially for you. We will have some examples from our marketplace, Jusan Shop. We will show you how we make product recommendations, and also probably some of you are basically annoyed by our that service, the notification personalization. Basically how we annoy and nag our customers in order to buy something. So the classical recommendation systems. From that point, I'm giving my word to Ruslan. Ruslan.
Good evening, everyone. So let's start from the classical approaches. There are basically two of them. It is a collaborative search and content-based. The main difference between them is actually that the collaborative search is based on users and content-based is based on items. Let's look closer on the collaborative search. What is the core idea of this method is to find other users who have maybe similar taste to yours and see what do they like, and then recommend you what you haven't seen personally, but other people who are similar to you have seen and have liked it. Previous slide. Wait. Back. One more back. Okay. Baujan, could you go one slide back, 2 slides back? Yes, 2 slides. Yes, this one. Yeah, this one. Why it's switching?
Okay, let me do the switching and you just talk and tell me to switch, okay?
Okay. So, collaborative search. Collaborative search. Basically, what we are trying to do is to find other people who are similar to us. How we can do this? This method splits further into 2 branches. Main branches is memory-based and model-based. In memory-based approach, we try to by brute force find closest neighbor to your taste. To do this, we need to measure similarity between you and other user. This can be done, for example, by measuring Euclidean distance. Let's say you have liked movie A, B, and C, and these A, B, C are 3 dimensions basically, and the other person have liked, let's say, movies B and C. So, but we don't know what he thinks about movie A. We are trying to predict what will he think about it, what will he like it or not. So we're trying to find the similarity between you and that person. We can measure the angle between vectors. This vector is produced basically by these 3 dimensions A, B, C. Like movies, it's coordinates since you put a rating to them. Or we can just measure the Euclidean distance as like a distance between 2 points between 2 vectors. This is memory based, and usually it is quite slow since we need to go through all pairs of users, and it's actually quite a huge number. Thus, there is a second method called dimensionality reduction to do so. Since we have a large matrix where we have rows where there are users, and in columns we have items. Usually, I don't think like a regular user sees every movie in the, let's say, Netflix. He sees only a miserable portion of it. Thus, many values are actually empty and unknown. Thus, the table is called sparse, or in Russian, разряженный. Since it's not densely connected, we don't have much dense information in it. Thus, we can apply, for example, singular value decomposition from linear algebra to split this matrix into 2. Like if we have matrix M, let's make it A multiplied by B, and thus we significantly reduce the dimensionality of 2 matrices and make our calculations way easier. Could you switch to the next slide? So we have talked about collaborative filtering, where we find similar users and trying to recommend what you might like based on like experience of other people. For example, if I like movie Transformers and Baujan likes it too, but Baujan also have watched let's say Inception. Probably I will like Inception too. In content-based filtering, we do an actually completely different approach. We try to find similar items. For example, people like let's say Inception is very similar to another Christopher Nolan's movie called the last one, Tenet. So if you like Tenet, most probably you will like the Inception, and vice versa. So we don't need other users, we don't need other users' experience. all what we need is to know the similarity between items, and we know it since it's like the same director, more or less similar actors. Thus, these movies are similar, and if you like one, most probably you will like another. Next slide.
Oh, may I add one more thing here? This is actually in collaborative filtering. It's one of the most probably the powerful tools to create the auditoriums, basically the groups of people to whom you want to advertise, but you basically know nothing about them except maybe their age, gender, their location, and maybe some little bit of financial information or activities. But in general, you basically know nothing about them. They never visited any products or never showed any interest or never actually even purchased anything. So the collaborative filtering might be very useful when you have a very big group of users about whom you have nothing, but you want to be specific about them and you want to show them the offers that are actually relevant. So yeah, that's.
So for example, as I said, in content-based filters, there are like linkages between items. For example, if you buy a laptop, you most probably will need a mouse, and if you buy a tea, you will most probably will need some snacks. It can be, in other words, it can be called like together viewed items or together bought items. If these, for example, items are bought together at the same time very often. But to do this, we need to have a strong knowledge about the items, their characteristics, to know how to calculate similarity between them, basically. This is the disadvantage of content-based filtering, since, for example, as it was said in collaborative search, we don't need information about items. We don't basically need information about the user himself or herself. We need to know what they liked from items, and based on this, basically based only on this information, what they have liked, what they have viewed, we can start recommending them. Next slide.
Okay, let me take over from here. So we will now talk, like we talked a little bit about how basically the companies, the majority of like maybe 99% of the companies approach the recommendation systems. Basically, the number one approach is they recommend the products and services from the viewpoint of customers and similar customers. On the other hand, we have the second approach where we recommend the products and services based on the properties of the product rather than on the properties of the users. So both ways are actually like there is none of them is bad, none of them is good. Each of these systems has its own use cases. So basically, let's talk about it. So when we want to find a lookalike audience, it helps us first of all better, like basically in order to find some audience, you have to research it. So basically it helps you to understand your customers a bit more. So let's say we have a small group of customers, which we call a source audience. For example, those are a group of people who are interested, for example, in, let's say, buying a honey. So they want to buy a honey. And they actually like visited the page that where you sell a honey, or maybe even made a purchase. So out of thousand people that you have in your customer base, let's say 7 visited the page with the honey. So the typical company's approach, some companies in Kazakhstan approach will be visiting, like basically advertising honey to those 7 people. This is actually very ineffective because these guys already bought honey. They don't need it anymore, probably for the upcoming months or so. So this is pretty much the useless way of marketing. The second way of marketing, the conventional ways, is basically offer that honey to everyone, which is also kind of useless because not everyone wants a honey. So what we do is we create some features from this source audience. In our case, like for example, here in this case is basically females, young females. So basically, we try to uh, take from our database some young females. We take them up and we offer them honey. So basically, what we did is we created a small, still small group of users, in this case, like maybe 10, 20 people, but they have a higher interest in buying honey. So it helps us to basically not to annoy people. And another advantage is that the customer's uh, time that he or she pays, for example, reading your notification or spending time in your app, is actually a money, and you don't want it to waste it. So basically, what you do is you try to show an offer which is valid for this customer. So how the look-alike machine learning algorithms work? Here, let's take a simple example of KNN. Here we have two axes. The vertical axis is age of the person, and horizontal axis is income of the person. So basically, if you are on the right upper corner, basically it's mirrored. In right upper corner, you are very old, high net worth individual. If you on lower lower right corner, you are high income young person. So this is only our two features for the sake of this example. Uh, let's say we want to find the people who owns a car. So basically, in Almaty right now it's snowing. In Astana probably it snowed a couple of months ago already. So let's imagine we want to find a car owners. So we want to offer them some new winter tires. So basically the safety feature. What we do is, this is the orange ones is basically our source audience from the previous slides. What we did is we basically just labeled them and showed on our 2D map. Those are people who own a car. But how we detected that they own a car? There are a variety of ways. Basically, we can, as a bank, we can have a look at their loans and see if there is, for example, if there is uh, auto loan after credit, we see that and we assume that the person have a car. Or maybe he makes a transactions on a gas station, the regular ones. It means he's definitely having a car because usually nobody goes to gas station to buy snacks. It's expensive and they're very inconveniently located. So we detected our car owners. In this case, on the left hand side here, we have people who own. So basically, they probably like because they have low income. Probably they drive more economical cars, like for example the Chevrolets or Russian Ladas, etc. In the middle, we have some people who drive the middle class cars, some Toyota Camrys, some Toyota Land Cruisers, etc. And on the very left side, we have actually people who drive high-end cars. Those are sports cars and some Bentleys or Rolls Royces. So basically, we detected three actually distinct group of people who drive different kinds of cars, probably. We don't know actually which car, but we just make an assumption here. Now, let's have a seat and develop an algorithm which will detect, which will expand our audience here. Let's say I want to say that, for example, if these gray dots, two neighbors are car owners, then the gray node, the person will be also a car owner. So let's apply this one. And we see that our model predicted that all of these green people are car owners. So what we do is we take our tires and advertise our tires to those people. And first of all, we expanded our reach. So we basically have more people to whom we can offer the relevant product at that time. And also because our selection, our populace is way bigger, even at the bit lower conversion rates, we will sell more products. So this is about how like lookalike machine learning algorithms work. But the tiny moment is that we don't have two variables. We have actually usually like 70 or 80 variables, like age, gender, number of events in the app, how much money they spend, how much loans they have, what is the like average transaction, what is the deviation of transactions, what kind of merchants they transact with, to which bank their money is transferred, who is the, even like what is the socioeconomic profile of the relatives of this person, or the economic transactions of this person. So basically, it's a selection of 80 or 90 variables that basically create this multi-dimensional space, as Ruslan mentioned previously, a sparse matrix, extremely large, extremely bulky. So from this matrix, we now train our model to find the car owners. And now, like basically, let's go to the roots. Which technologies we use in order to create these models? Actually, that's one of the easiest parts. Actually, most of the NU students already familiar with those. First of all, to create basically any recommendation system, probably you should like have some experience with them as a user. So right now, I recommend you to go, for example, to Technodom website, to our hated competitors Kaspi, to Jusan, to any marketplace. Amazon has amazing recommendation system. Go there and just start looking which kind of products they are offering to you. Even go to Netflix or go to Yandex Music or Spotify. When you go there, they offer you some kind of tunes to listen or movies to watch. Even that is a recommendation system. And try to make a guess how the hell this system is offered exactly the movie that you wanted to watch. Or even in Google Maps, when you open some location, they show you like, for example, when you are looking for restaurant, it shows you that like it's 89% match or 95% match. And usually it's true, basically, based on your previous visited places. It makes a good approximation of what kind of food you like. Because people similar to you basically visited similar places. Now, in our case, for example, for content-based filter, we offer the refinance of their loans in other banks. So the user gets basically a better deal with a lower interest rate. We use our databases basically to create a pool of clients based on their transactional activity and find the similar users. And also we try to predict the user's future needs. In our case, using, like, for example, in collaborative search, whenever you, let's say, you buy an iPhone, what you will do? The first guess will be like, go ahead and buy a case, right? The first thing that you do whenever you buy a phone. So that will be a typical recommendation of any marketplace that sells a phone. And the thing is, the mobile phones actually, like, they are relatively low marginal product, but when you sell a case is incredibly marginal. It's like 70-80% margin on some marketplaces. And then the typical Apple users or Samsung users, they go ahead and want to buy, for example, the AirPods or some headphones. Then after that, maybe your charger will grow. Basically, it's a sequence of events that happens for maybe 70-80% of the users, and they will buy that product anyway. So why not offer it for them? As I said in the previous, the tire, whenever you buy a car, in 2-3 years, the person will buy some new set of tires, or he will renew the insurance in each year. So basically, you know when the events will probably happen. Even with the phone ownership, whenever the person buys a phone, usually they change their phone after 2 or 3 years. So why not to offer a new phone at that point? Now, if we speak from the perspective of hard skills, so basically the previous one is basically like business knowledge of the things, of the recommendation systems. Like, you basically, it's your expert knowledge as a person or as an employee in the bank. You know, like, what kind of demand is coming. Now, another set of skills is hard skills. Those are basically the skills that you need in order to develop an algorithm. The number one thing in our stack is, of course, the Python language and all of the surrounding libraries. Those are like the PyTorch, the Plotly, the Seaborn, the TensorFlow, the Jupyter framework, the Pandas, the NumPy, etc. Then, when you start growing, you would like to develop the algorithms that are more efficient and work faster. In order to do that, you have to switch to faster programming language. In order, like, to be honest, Python is a bit slow programming language because it is a script programming language. It's not, you don't basically generate the machine code before executing it. So Python, because of that, is a bit slow, comparatively slow. It's still incredibly fast and efficient, but when you are working in production environment, those milliseconds actually matter a lot. Whenever a person, for example, comes to our bank, whenever they open the app, we want the person to be logged in matter of seconds. Whenever he opens any place, we want the person to get the information at finger snap. So what we do is we try to switch another programming language, for example, the C++ or Java. Then also it is important to know the basics. So if you know how to program in C or assembly, that means that you manage the memory efficiently. It is a very important skill because on our machines in Jusan, for example, when you're working, they are incredibly powerful. But the thing is, if you don't manage that properly, your code might run away in RAM and consume a lot of RAM. Like, for example, in our data center, we had one case when in the environment, one script was taken up in the RAM around 700 gigabytes. So that is a very bad use case. So basically, you have to manage the RAM and CPU usage. And in order to do that, you have to know how the operating system basically manages those. On the other hand, we always have a flow of data that is incoming to bank and the flow of information that we are outputting. The flow of information that is incoming is basically the stream of data. In our cases, the user is authorizing, clicking, moving, swiping, maybe ordering something, making transactions, putting their card on terminals. So all of that information is incoming. So what we do is we create the data broker. Basically, we have a data broker. It's Apache Kafka. The code is written in Python or C, and basically the Kafka allows us to ingest the data at incredible speed. And then what does the Kafka does? It keeps the information in the memory, and the databases are typically slow. So basically, it slowly puts those information in databases for later processing. So basically, it allows to ingest the data at extreme speeds, but whenever it has time or database is like basically slower, it slowly puts the data into database. And sometimes during the day, we have the data surges. Whenever we like create an amazing offer, there are like, for example, 2,000 users per minute incoming. What do? Is we don't put like all of that information immediately into database. We store it in Apache memory, and then whenever users go away, we start putting the accumulated data in RAM to the database. So it's basically efficient way of dealing with data. Also, we have the ETL tools, exchange, transfer, and load, using Airflow and Informatica. Those two tools allow us to take the data from the production databases. For example, there is a system called Wave, which basically manages the transactions of the debit cards. And the thing is, you cannot go ahead and do a select on a production database where your credit or debit card is processed, because even the single select by the user actually I'm sorry, slows down the real execution of a transaction. So if you're doing selects on production database, this is a very bad thing to do. So what we do is we, at night when nobody is using the system, or small amount of users using the system, they are always there, we take those data and transfer to another database. In our case, it's Greenplum or ClickHouse or Postgre or Oracle. We move the data, and then we can do the analysis. For example, see like what kind of transactions the user did. Basically, we can do all of that hard work on the database, which is not directly connected to production environment, which allows us to be incredibly fast. Then we have APIs. APIs is basically the endpoint they are designed to answer very small specific questions. We send the question, for example, we send to the user, to the endpoint, the phone number, and it returns the in to us. In is in, basically, in Russian, yeah. This is a very small endpoint. Or, for example, the phone number and returns, for example, the latest 10 transactions. So it's very, very small thing designed to react fast and integrate with other systems. Then we have the search engines, Elasticsearch, Kibana. On the front end, we develop in Node.js and Streamlit to visualize the instruments to be used by our employees. And then, of course, as a data science department, you want to analyze and show some graphics, graphs or charts. Those we do in Grafana and Power BI. Grafana is open source, Power BI is paid. Now, all of that huge stack has to be run on something, right? You have to execute it on something. You cannot go ahead and execute it on the operating system, because what will happen if your machine breaks? Like, there is a flood in Astana and our data center is underwater. This is, so basically, don't run your code on the machine itself. What we do is we run our code in Docker, Kubernetes, or Kubeflow, and this allows us to move our code in case there is something wrong with machine, or another case, when we have a lot of users coming in. What happens is that Docker allows to create additional instances of the same worker to expand horizontally. And then all of that, of course, is at the end of the day run on the operating systems, which is Red Hat and Ubuntu Linux. Now, on this slide, there are two Pokemons hiding in the plain sight. In the comments, please answer, find these two Pokemons. If the person finds these two Pokemons, we will send you merchandise as a gift. We will give you merch. So maybe take a screenshot, and then after like 5-10 seconds, I will move to the next slide. Okay, moving to the next slide. How we use the recommendation systems. At the end of the day, everything that we are showing today, everything is designed to earn the money. So what we do? First of all, we show the специально для вас section in our Jusan shop. Here, Ruslan, could you tell us more about this?
Yeah, sure. Actually, this is my main project at Jusan. One moment. Basically, there are many directions of recommendations in Jusan shop. It's not only special for you section, it's also others, and others also in development. Let's go over them briefly. So first of all, we need to start with the data, and the main source of data in Jusan shop to make recommendations for you is actually your views, your clicks on categories, on items that you maybe liked something, you have put something into the cart, but later decided to not to purchase it, or you have purchased it. So all of this data is actually logged, and we use it to actually see what do you like. Also, we have at the end of the day, like computed statistics, most popular items or most popular categories of items. Maybe something new have arrived. Maybe, let's say, Samsung have announced a new phone and it's like hits the charts. So all this information is used to produce the recommendations. But how? Currently, we have content-based filtering as for long-term recommendations. What do I mean by long-term? Let's say you have used Jusan shop one in half a year, or maybe like you purchase something and then you forget, and then after several months you remember, oh, I have like Jmart, Jusan shop, and you start looking at it for something that you want to purchase. The problem is that we can't precisely predict your interested products, since there's actually a large gap in time, several months, let's say. But we know, like in general, that you like, let's say, electronics, laptops, or like you're interested in it in general. So this is our long-term memory for recommendations. Or maybe you have a car, so definitely like you will need something for a car even after half a year. Then we have a short-term recommendations. Let's say I'm searching for a new camera and I'm looking for one model after another for let's say for a week. Actually, I do so. I'm researching what I'm going to purchase. Thus, we look what other people who all searched for cameras, what they have purchased or what they have used. So we use a collaborative filtering. Like we're trying to find other persons who are trying to find similar things and see what did they at the end up with, and we try to recommend it. But we also have new users who haven't purchased anything, who are completely new to our platform, and we don't know basically anything about them. To deal with them, to produce recommendations to them, we use cold start, slightly improved with KNN, it's a modification with KNN to find, to find recommendations as soon as possible without a large history of view, a large history of purchases, and so on. Like we're trying to predict your lookalike audience and find that group of people, and then from that group of people we can try to recommend you something. However, this is only the generation of recommendations. Like we produce them, but maybe not all of them are actually useful. Let's say you have already purchased something, or we need to sell something particularly, or maybe the product that our algorithm recommends, we know that nobody interested in it for some reason, or maybe it's not non-profitable. To stop all such things, we use an extensive filtering after the generation of recommendations. We use item groups to filter out similar items, so that you don't receive a bunch of the same iPhones on the same page. We try to make a variety of in recommendations, so to broaden them. We use filtering with prioritization. Let's say some items are more it's more important to promote them than others. So we have a kind of handcrafted prioritization. We use sampling to, let's say, we have prepared a bunch of recommendations for a day, but we don't want to show you the same recommendations over the day. We're trying to show you as much different items as possible. To do so, we prepare a cache of recommendations, and then from that cache we are sampling a small portion with a random sampler to provide you some updates throughout the day without the necessary computations. Couldn't switch to the next slide. So we have talked basically about personal recommendations, where we recommend products for a user based, for you, based on your view history and so on. But we also produce item-based recommendations. Let's say, as you can see on the right on the screenshot, we have a page of an Apple smartphone, and we know that usually people are interested in buying headphones after they buy the iPhone. Or, as Bauran said, it might be a new case, or for example, as let's say, car, you might be interested in some car accessories. So we are trying to predict those similar items, like to find similarities between different items. To do so, we firstly need to parse the full catalog of our products that we are offer. We use different hybrid linkings, starting from simple brand-based, like Apple goes to Apple, Samsung goes to Samsung, and so on, or maybe like what kind of Apple brands, maybe like Sateki hubs for MacBook and so on. So we know that these products are linked, or at least they are more linked than like completely random product. We try to search for products which are viewed together within a short period of time. Let's say I have searched for a camera and then I'm searching for lenses within an hour. Let's say I have switched like my interest and starting searching for lenses. From this, the algorithm can predict that this particular camera is linked to a particular lens, since I have watched them together in a short period of time. And let's say another person do so too. We build confidence in our model by looking through all users' history. And also we apply with the same filtering, collation, and sampling to produce like clean recommendations, to avoid duplicate recommendations, or like to avoid recommending the same thing throughout all day. We don't want it. We don't want to first annoy you, and we want to actually show you more recommendations. Next slide. And here you can see actually the schema for our recommendation engine for Drousan Shop. Actually, what you see on your start page, like recommended for you or special for you, you can see it here. We have our data warehouse, which stores all this information about your clicks, your views, your purchases. And then in Airflow, we have a bunch of workers, bunch of tasks that are executed every day, once a day. They are completely isolated. They are not. They do not communicate between each other. They just work and produce their own type of recommendations. So let's say recent recommendations is what I have watched on a week, and this module tries to predict what I want to search like right now. General recommendations are trying to produce my general interest, predict my general interest, like if I'm interested in electronics, trying to predict something like let's say most popular in electronics right now. We have also bank activity analyzation, like what kind of transactions you make. Maybe you have opened a loan, or maybe you have opened a deposit, and so on. And we also have like two fallback models, random recommendations and cold start recommendations. They're like the critical measure if the user is completely unknown and we need to recommend him something, but we don't basically know much about him. All these things are collected in a intermediate table in database, which is then passed through the filter. As I said, filters out all these unnecessary products which you maybe already have bought and you are not interested in it, since we can see it from the transactions. Like maybe you have bought it in Drousan Shop, so we don't need to recommend it anymore. Or maybe this product is unprofitable and we don't basically want to sell you, like how can I say, we want to sell you but it's not really profitable, so we would like to use this space in recommendations ribbon to promote more valuable products. And then filtered recommendations are passed through the collator, which assigns, we have like maybe invented a term, item groups. What we're trying to do is to smartly collate items into different groups. From the simple point of view, it can be just categories. Let's say we don't want more than one item from one category. So we don't want two smartphones from the smartphone category. We want one smartphone, one, let's say, headphone, and so on. This is the simplest case. More advanced is maybe we want to link it with a price category. Like we want two smartphones from the same category, but they should be of different prices, one for budget option and one for more pricier. All these things happens in collator, which then passes the data into a Redis database, which is directly connected to the web API through the sampler. What is Redis? Redis is actually a very fast database which operates in memory. So it doesn't use an SSD or HD, it uses main system memory to store the database. Thus it's very fast and responds in like milliseconds. Why it's crucial for this case is we need to respond with recommendations as fast as possible. Thus conventional databases are usually not the case, do not comply with the requirements since they're a little bit slow. When a request comes to web API, it triggers a sampler, which then goes to the Redis database. What it does, sampler is actually an interesting thing, since in Redis database we store like a bunch of recommendations, let's say 100 or 1,000 recommendations for one user. Usually we store about 100. And what the sampler actually does, it takes this 100 and tries to intelligently sample, let's say, 10 recommendations from it. Why do we need so? Why? Because it's like unnecessary computations, but it actually saves us time since we can produce these 100 recommendations at night when nobody, or not much people browse our shop, and we produce this bunch of recommendations for each user, and then throughout the day we can sample small portions from this bunch of recommendations to produce different recommendations throughout all the day. Like you open your app in the morning, there is 10 recommendations, and then you open, let's say, in the noon, and there might be completely different recommendations. It's not hardly based on the, like, we have shown this item or not. It's basically more advanced and based on prioritization of different items on the item groups, so that we don't include two items from the same item group, so we like avoid duplicates in our sampled how can I say, set. Yes. And finally we pass to web API, which is basically built on the fast API, since it provides very fast response time, and which we very need. So as you can see in general, our architecture is very modular, so we can like add additional module whenever we need, or we can switch off any module that we don't need. The filter module is actually similar to user recommendations. As you can see, it's not shown, but within it we store different filter modules. Each filters out its own unnecessary items. Like one filter cuts purchased items, another cuts unprofitable items, and so on. Collator is collator. This architecture allows us to be very flexible with marketing department, and whenever they have a new not recommendations, but a new tasks that we need to promote something, or we need to shut down one sort of type of recommendations, we can easily do it, and the next day recommendations are completely different, and it doesn't require the like actually rebuilding the whole system. That's it from my side. Orjan.
Yeah, thank you for this deep dive in the architecture of our system. Another way of recommending is actually how our home screen in the app adjusts for each user. In this case, on the left side, you see that the user is offered the loan, the payday loan, the refinance, and the deposit. On the right-hand side, the user is offered the loan, the refinance loan, and also the car insurance and child's card. So we can basically see that the person on the right-hand side has a car. So basically, we are offering him to buy some insurance from us. Also, another use case is our call center. And the main goal is here to basically predict the user's desire to ask a question. And here the recommendation system works in very, very different way. We are offering our user a solution to his problem. Because remember, never ever person calls to call center to say thank you to us. It's always a problem, and we can understand that. And what we must do is to offer the solution as fast as possible. So user calls us up, and we want to basically know what happened to him. He never calls like just to say something. It's basically a failure in transaction or failure in some system, in this case of user, and we need to fix that. So what happens is that whenever a user picks up a phone and starts calling us, our system goes around our systems and starts looking what happened to that user, why he is asking for, like, why he is calling us. And whenever, like, basically it takes maybe 1 or 2 seconds, we ask all of our systems what happened, and then we reply to the user, you are calling us because you have some failed transaction. And we tell the user that, okay, man, we saw your transaction, have a look at the card number, there is probably a mistake there. So basically, we recommend the user the solution even before he has an ability to talk with the person. It has actually 2 upsides. The first upside is we need to have less staff on premise to deal with that. The second advantage is that our staff that is already working on premise have more time to deal with the person, more quality time. So we have more time to talk with the person who has actually a bigger problem, and we have more time to research his problem and offer him a good solution. And also, as I said, I think it's duplicate slide, no?
Yes.
It's duplicate, right?
It was from the from the middle of the presentation.
Yeah, it's from the middle. We talked about that. And also, the next part is how we deliver these recommendations. Yeah. Whenever you are in the app, we deliver it to you through the user interface. The second part is how we deliver the push notifications. And the thing is about push notifications is if you send 1 million push notifications in, let's say, 5 minutes, you will crash app. You will crash your app because believe me, no bank in Kazakhstan can handle 1 million people per minute. There is no bank that can handle that. So what we do is we distribute those notifications throughout the day. So they got delivered throughout the day slowly. And also each person has its own resistance to push notifications. So for example, me personally, you can send me the messages like 2 or 3 times a day, I don't care. Ruslan, for example, he doesn't like to be bothered. So to him, we send the notifications maybe once every 4 days. There are even people to whom we send the notifications once a week. It all depends on the user and how frequently he opens the app. So basically, we decide based on the user, not on the some rule. Basically, we have a look at the user, we see how frequently he reads the notifications and see, that one reads like 30 times a day that section. Let's send him like maybe 10 times a day. But if he reads once a week, we will send him the notifications once a week. And also like it creates different scenarios with the user. For example, if we see his interest in Technodome, but he for some reason didn't choose our bank as a loan provider, we will anyway send him some offer like go ahead and maybe use taxi in Jusan app because Jusan app offers amazing bonus on taxi. Or maybe the user started a loan but did not finish it, and we start to annoy him like, come on, take a loan, it has a good interest rate, or we have like a bigger value, or the monthly payment is lower. Then we remind the user like you have to pay the monthly payment. Or hey guys, for example, when the war in Russia started, we send it to our clients, hey guys, those who only to those who are in Russia, hey guys, the bank will stop working in a week, so please take out some cash from ATMs because we will not be able to service you. We motivate the people to switch, like to spend more with Jusan and move up in the bonus category. And we, of course, send the targeted push notifications. So on that, I would like to end. Thank you for all of you. Thank you, Ruslan. It was very nice to have you here. And if you have any questions, please ask in the chat. We will be here for like 3-4 more minutes. Thank you, everyone.
Thank you, Borjan. Thank you, Ruslan. Guys, if you have any questions regarding this presentation, regarding recommendation systems, or about the upcoming hackathon, you may ask Borjan or me. If you have some organizational questions about like, dates, times, or what is the format of tasks. If you have any questions, please hurry up because we don't want to take too much time from our precious guests.
No.
Yeah, I believe there are no questions. But remember, in the last presentation, we were asked a lot of questions. So, anyways, during hackathon, we will also have a Q&A session, and we will be online.
Yeah, probably when everyone will see their tasks, they will have some questions.
Yeah. All right.
All right, then.
right.
Thank you again.
Thank you very much, Maxim, and we will send you the merch once it arrives to Astana.
Yeah. Okay. Goodbye.
Bye.
Thanks, everyone. Thank you, Maxim.
Thank you, everyone. Goodbye.
Goodbye.